What's up, all you badass programmers? So today we're going to talk about the difference between arrays and linked lists, and our goal here is going to be to store some integers. So let's say we have a segment of memory here, and let's say integers in this architecture are going to be 4 bytes. So each one of these little blocks is going to be 4 bytes and going to store one of our integers. So let's say we have 1, 5, 7, 9. And so let's say that we're trying to keep this array sorted. So this means all of our elements are going to be in increasing order. So a key property of an array is the fact that all the elements in an array are contiguous. So what this means is that each element in our array is going to be adjacent to the next element. So the first element is adjacent to the second element is adjacent to the third element, and so on. So when we're dealing with arrays, so for instance, let's use the C programming language, you're going to need to declare the size of the array. So in C, you're going to always declare the type. So we're going to have an integer array, and this is the name of our array. And in this case, we're going to say we want our array to be 5 elements, which means we're going to actually allocate 20 bytes, 5 elements times 4 bytes for each element, so 20 bytes total for our data structure. So now what we're going to look at is, what if we now want to insert the number 2 into this array? And remember, we're trying to keep our array sorted. So what's going to end up needing to happen is we're actually going to need to allocate another array. So let's say now we have our second array, and it starts at memory address 80. So now what we're going to need to do is copy over our first element, insert our 2 that we want, and then we're going to have to copy the rest of our elements, 5, 7, and 9. So we see already a disadvantage of our array is when we want to do this kind of insert and maintain the order, we're actually going to have to reallocate another array and copy over all of the elements. Now let's say we want to add the number 10 to our array. So now we're going to run into an issue because our array is already at capacity. So we already have our 5 elements. So now what we're going to have to do is actually allocate another array, and we actually are going to need to make sure our new array is actually larger. So now instead, our original array is going to be, well, we can double its size, but in this case, we just want to add 1 element. So let's just say we're only going to increase its size by 1. So now our new array is going to have size 6, and now we're going to have to copy all the elements from the array. So this is 1, 2, 5, 7, 9, and then 10. So anytime our array is actually at capacity and we want to add another element, we're going to have to reallocate an even larger array and copy over all of the elements. So we can see a con of our array is that when we're trying to write elements, sometimes it's going to be a little bit slow. It's going to take linear time. We're going to, in the worst case, have to copy every single element of our array. So now an advantage of our arrays is actually going to involve something called the CPU cache. CPU cache. And so we're going to use a little analogy to try and understand what the CPU's cache is. And so a CPU cache relates to our computer's memory in a similar way that a refrigerator is going to relate to the grocery store. So the idea here being that access to our cache, similar to access to our refrigerator, is going to be relatively fast, while going to memory and or going to the grocery store to get your items is actually going to be relatively slow. So now let's think of an example in the context of our refrigerator and grocery store. And let's say we're trying to make an omelet. And the ingredients to make this omelet are going to be eggs, milk, and tomatoes. So let's say we already went to the grocery store last night, and in our refrigerator, so this is going to be our refrigerator, we already have our eggs and our milk. So when we're going to make the omelet, we already have two of our ingredients. So as we're making the omelet, we realize that our last ingredient we don't have. And so first what we're going to do is we're going to check our refrigerator. And so in our refrigerator, we see that we have eggs and we see that we have milk, but sadly we don't have any tomatoes. So now what this means is we're going to have to go all the way to the grocery store to fill up our refrigerator again. And this time we're going to grab our tomatoes. So now when we go to look into our refrigerator again, we're actually going to have our last ingredient. So similarly here, our CPU cache is going to allow us faster access to the items that we have in memory. But sometimes when we're looking to our cache, the element we want isn't going to be in there. And that's called a cache miss. And so we're going to have to travel all the way back to our main memory to get the data we want. So now for our CPU cache, let's read in let's say our cache can fit 3 elements, 3 integers. So we're going to our main memory, which is like our grocery store, and we're accessing the first 3 elements. So here we have our CPU cache. Which is like our refrigerator, and we have 1, 2, and 5. So let's say we want to go through every single element of our array and print it out. So we start off with our first element, and we see that it's in the cache, so we're able to print that. Our second element, we see it's in the cache, we're able to print that. Our third element is also in the cache, so we get that for free as well. So now we run into issue when we're trying to get our fourth element is first we check the cache and we notice that our element is not there, which means now we have to make the expensive trip all the way back to memory and grab the next block. And so now the state of our CPU cache is going to be our 7, our 9, and our 10. So then when we print out our fourth element, now it's in the cache. And then we want our fifth element, which is in the cache, and then our sixth element is also in the cache. So in total, we took 2 trips to main memory so that we could print out every single element of this array. So this is a convenient property of an array. Because the memory is contiguous, we're going to have to take fewer trips to main memory. So in summary for an array, our pros are that our reads are fast reads. Meaning we're going to be able to minimize the number of times we actually have to go to our memory, which means we're minimizing our total number of cache misses. While the cons would be slow writes. So before, when we wanted to add an element when our array is at capacity, or if we want to add an element at a certain index, we're actually going to have to allocate new space and copy over all of our elements in the worst case. And then finally, another pro of an array is actually you can access by index. So what this means is if we want our fourth element of our array, we can figure out exactly where that is because we know the starting address of our array. So that's wrapping it up for arrays. So next we're going to talk about storing our data in a linked list data structure.